Okay, now we get into a few application problems. This one's real similar to one of the questions you have on the quiz. I didn't do a problem for each application. I'm hoping that after you get the hang of it, that the application problems will make sense with just these 3 examples. Oh, I take it back, just 2. Okay, so a popular game sold for $260. The price of the game was adjusted annually by just enough to keep up with the 5% inflation each year. For n greater than 0, let p be the price of the game n years after it was put on the market. Define p recursively. This is a little bit confusing because all we have to do to calculate the next year's value is take the current value and multiply it by, well, 5%. But the way we multiply by 5% and still retain all of the original value is to multiply it by 1.05. And do we add anything? No, it's just a plus 0 because the previous year's value, so when we get to calculating the year after its initial release, p of n plus 1, p of n is just going to be the $260 times 1.05. Now the reason they're doing this is because they want us to come up with an expression for p of n in terms of just n. So the way that works is it's really just an exponential expression. P of n is going to be equal to the original price, $260, times 1.05 to the n power. So it's as though we multiply that 1.05 multiple times. Exponents will take care of all of it. What was the price of the game 5 years after it was put on the market? Well, P of 5 is going to be 260 times 1.05 to the 5th power. And when I plug that in, I get $331.83. That didn't work because for whatever reason they want us to round to the nearest dollar. So, you know, if you think you're entering the right amount and it gives you the bad red, not the good green, then look and see if maybe you just weren't rounding the way they asked you to. How many years after the game was put on the market did the price first exceed $300? So this is kind of important because it'll show that we have to go up 1. But let's do the math. We want to know when the price exceeds $300 from our equation. So we're solving for n the number of years. Remember, we're solving an exponential equation. We're going to use a logarithm. First thing we're going to do is divide and get that exponent all by itself. Now what I like to do is I like to simplify this, but not give it a decimal because I'm going to lose numbers due to rounding if I mess around with decimals. But 30 and 26 are both divisible by 2. So what I'm going to work with here is 15 over 13. So 15 divided by 13 is equal to 1.05 to the n, and now I'm going to apply a log to both sides. That's going to, and the log is the base of my exponent, so log 1.05 of 15 over 13 is equal to n. Remember, if I apply a log base 1.05 to an exponent base 1.05, those both cancel each other out. All right, typing that in, I get n is approximately equal to 2.93. So at 2.93, it will exceed $300. So they asked us to round, I think, to the nearest year. So we're going to put in n equals 3. It goes up by whatever year that you calculate, just round up to the next year. Okay, on example 9, we've got a pendulum that swings 12 feet to the right on the first swing, and on each swing following the first, the pendulum swings 2/3 of the previous swing. Write a sequence for the distance traveled by the pendulum on its first, second, and third swing. Well, they told us that it swung 12 feet on the first. On the second, it's going to go 2/3 of 12, and that would be 2 times 4, which gives me 8. And on the third swing, it's going to be 2/3 of 8, which won't reduce at all. It looks like I'll get 16/3. Okay, so there's my the length of my first, second, and third swing. General rule is going to be, we're going to start with the amount times 2/3 to the n-1. And the reason we're going n-1 is because if we plug into this equation at n equals 1, we want to make sure we just have a 12 left. So that 1 minus 1 gives us a 2/3 of 0, which goes to 1, which gives us the 12. How far will the pendulum swing on its 10th swing? Well, now that we have a formula, we're just going to plug into that. To the 9th, and I think they asked you to round to the 100th. I got 0.31 feet. And we're done with the examples for 10.3. See you in class.